Good morning, everyone. Thank you very much for coming out to Research Talks. I am Sharmeen Dean, the Vice President Research, and we have a fabulous selection of speakers for you today. The session is a little bit different than what we've held previously. It's in the form of a panel discussion, and it's the topic of the panel discussion is societal impacts of 21st century technologies. I will let you know that we are going to be running several more of these panel discussions coming in the winter term with an interdisciplinary perspective being brought to a variety of topics. I'm really thrilled with the panelists that we have been able to assemble here today. Ian Goldberg is a professor and university research chair with the Sheraton School of Computer Science. His research is in the area of privacy-enhancing technologies, tools that keep people safe and secure and private online. He received his Bachelor of Mathematics in Pure Mathematics and Computer Science from Waterloo, and his Master of Science and PhD in Computer Science from the University of California, Berkeley. Thank you very much for being here, Ian. Kate Larsen, also a professor with the Sheraton School of Computer Science, has research interests in artificial intelligence and multi-agent systems. Her expertise lies in preference modeling, group decision-making, and strategic issues arising in multi-agent systems. She received her Bachelor of Science honors in mathematics from Memorial University, her Master of Science in Computer Science from Washington University, and her PhD in Computer Science from Carnegie Mellon University. Thank you for being here today. Jennifer Whitson, an assistant professor in the Department of Sociology and Legal Studies, examines the secret life of software, mostly at the nexus of digital games and surveillance studies, and has been conducting ethnographic fieldwork with game developers since 2012. She received her Bachelor of Arts in Criminology and Master of Arts in Sociology from the University of Alberta and her PhD in Sociology from Carleton University. Thank you for sharing your perspectives, Jen. Alex Wang, an Associate Professor in the Department of Systems Design Engineering and also a Canada Research Chair in Medical Imaging Systems at the University of Waterloo. His area is computational imaging. His focus is integrative computational imaging systems for biomedical imaging, and in the area of artificial intelligence, his focus is on operational artificial intelligence. He received his Bachelor of Applied Science honors in Computer Engineering, his Master's of Applied Science in Electrical and Computing Engineering, and his PhD in Systems Design Engineering from Waterloo. I'd like to welcome our four panelists and thank them very much for some thoughtful discussions prior to this panel presentation and let them know that we're really looking forward to their presentations today. We're going to start with some brief talks of introductory nature by each of the panelists, and then we'll invite the panelists to sit up front in an interactive experience with the audience as we share thoughts all together on ICT technologies and interactions with communities. So we'll start with Ian.
Thank you all for coming. So I'd like to first just start, as was mentioned, my area of research is privacy-enhancing technologies. I'd first just like to start by defining the term. So the first word is privacy, and this is a surprisingly difficult concept to define. A lot of people think of privacy merely as secrecy, merely as hiding personal information, keeping things confidential. But that's just the barest piece of privacy. Privacy is a much broader idea. Privacy is about freedom, privacy is about autonomy, privacy is about self-determination, privacy is about human rights. Privacy is the ability for a person to choose for themselves what they want to say, what they want to read, who they want to talk to, what they want to talk about, how often, when, without external undue influence. Privacy is the space that allows a society to grow and allows individuals to grow within that society. It's particularly important for young people, for members of minority groups and oppressed groups, in order that they come to a sense of their own identity and to be able to find others like them and form community. So privacy-enhancing technologies are systems, tools, software, products that allow people to maintain their privacy, particularly when they go online. The kinds of pets, privacy-enhancing technologies I mainly deal with are ones for the internet. So the first pets for the internet kind of came about decades ago. The earliest, really one of the earliest ones was called PGP. You might have heard of it. It allowed people to send email encrypted, right? So you could protect the contents of your conversation. Now, the user interface of PGP, I have given an example up here, was extremely complicated and really hard to use. And there's this long line of papers called, the first one was called Why Johnny Can't Encrypt, and then the second one is Why Johnny Still Can't Encrypt. And there's like this long line of papers exploring exactly how hard it is to use this particular piece of software. And it is terrible. There is no denying that PGP's interface is horrible. But we have come a long way. We have not made a lot of progress in the email area, but we've moved on to other forms of communication that are somewhat more common today. So things like instant messaging and mobile communications. So today, the only user interface is this little thing that says private here in this instant messaging application. Over here is iMessage. If you use an iPhone, you're probably familiar with iMessage. You may or may not be aware that it is encrypted. Where is the little lock icon or whatever showing you it's encrypted? There isn't one. It's just transparent, and that's perfect, right? We have come to the place where protecting the contents of your communication is now something we can do pretty much automatically and transparently, and that's awesome. So these kinds of technologies, as I said, protect the contents of the communication. There's the most popular privacy-enhancing technology, the one most widely used, is this one here. No, not Tamer over here. Here, let me zoom in. It's this one that you probably see in your browser every day. It's the S. This letter S here, and maybe this green lock, but mostly the S, stands for secure. And this means that you have accessed this web page in a secure fashion, and all of your interactions with that website are encrypted. And that's great. Since several years ago, when famously Edward Snowden revealed that there was way more surveillance of the internet going on in the US and around the world than most people had hoped was true, even if they feared it was true. Those revelations caused a big upswing in the adoption of privacy-enhancing technologies. And one in particular was TLS, where one of the hard parts of deploying TLS is, you have to convince companies to run TLS-enabled web servers. So companies had to do something so that when any person on the planet visits their website, they are protected. Okay? But because of this, that has seen a big upswing recently. So here's a graph over the last 2 years of percentage of pages loaded over HTTPS. And you see it's now up to like 2/3 or 3/4, depending on which operating system you're using, and growing. So that's great. So we're well on our way to protecting all of the content of web traffic online. But content is only part of the picture. A much more pressing problem is protecting what's called the metadata. So the metadata is the information about the communication. Your identity, who is talking to whom, how long, how often, and this kind of metadata is extremely sensitive. In fact, General Hayden, the former director of the NSA, famously said, "We kill people based on metadata." And so we want to protect people from being killed based on metadata. That's kind of my position on that. So protecting the metadata is the next big step. The main technology in this space is called Tor. Tor, in its normal usage, is something that individuals can use to protect their own identities when they go online. So when they connect to a website using Tor, it doesn't automatically reveal information about their IP address, their name, their location, and things like that. So that's great. But more recently, there's a new thing called onion services or single onion services that Tor provides that's more like TLS in that companies have to choose to deploy it. But if a company deploys it, it means anyone visiting their website using this advanced technology has more security and more privacy than just connecting over TLS, because it doesn't only protect the data, it also protects the metadata, and thus protects people from things like spear phishing attacks and stuff like that. There was just a phishing email that went around just an hour ago on campus. I don't know if anyone's seen that yet. Don't click on it if you get it. It will take you to a fake like UWaterloo login page, and it's trying to harvest your password. Do not do that, okay? So those kinds of attacks are what are prevented by things like Tor. And these onion services, these onion sites, are starting to be deployed by companies. The first big company was a few years ago when Facebook deployed one of these onion services, and the most recent big company I know of that deployed it was just a month or so ago. The New York Times deployed one of these services, so that this is what the Tor browser looks like. It's basically a version of Firefox. And the only thing to notice is instead of it saying newyorktimes.com here or nytimes.com, it's nytimes.onion. That's part of the cryptography thing. So nytimes.onion. And you're visiting the New York Times while protecting your metadata in addition to your data. Okay, so that's it for my intro talk. So privacy is about lots of important things, not just about hiding information. Pets keep people safe, secure, and private when they go online. HTTPS has been very successful the last few years and is a growing fraction of web pages on the internet. And protecting metadata in addition to data is the next step for privacy and security online. Thank you very much.
Now I want to thank Ian very much for his talk. We're in the same, department, both at the School of Computer Science, and we are in very different research groups, and there's like different questions keep us up at night. But we are also, at our core, we have a similar problem. He's very interested in keeping sort of data and information private at appropriate times. I'm very interested in how do we make group decisions from, on behalf of a group or a population which are considered to be good. And in order to do that, we need information about the individuals. And so an interesting problem is, what is the right criteria? When can we actually make high quality decisions on behalf of a group, sort of with limited information? So when I was asked to present here, I wasn't given much guidance. They said, talk about your research. And so what I'm going to do is to sort of lay out some of the questions which drive the problems that I find most interesting, and then give you some examples of the work that my group does. Now, my research group, we work on problems from sort of our highly theoretical to the very, very applied. So in particular, all the way from using ideas from social choice theory and game theory to looking at very applied domains, such as work that we've been doing with Wildland Fires. So in particular, I'm interested in a field of artificial intelligence. Well, I'm interested in AI broadly, but my particular area which I love is something called multi-agent systems. And in particular, what I'm interested in is how do we make decisions, or how do we design environments where we have multiple interacting agents. And by an agent, I mean humans, software agents, computer programs, robots, really any form of decision maker. And then the questions that I ask are the following. So in particular, if you have a group, how do we make a decision on behalf of the group, which appropriately reflects both the preferences and values of the group members themselves. So this is a place where information about the individuals becomes very important. I'm very interested in strategic behavior. So in particular, I'm interested in understanding what type of strategic behavior might arise in different contexts, and how does limited information as well as limited computational capabilities influence the strategization that might arise. And then finally, I'm interested in how do we reason about and design systems, particularly in computational settings or where there's some core computational problem where we can actually handle the strategic behavior. And so what I'm going to do for the rest of my few minutes, I'm going to give you some examples of problems that myself and my graduate students have worked on, which highlight some of these three different aspects. One thing that I've been very interested in recently is voting. And this could be voting in the form of elections in a political context, but also more broadly. So, just sort of when we're trying to make a decision as to where we're going to go out for lunch after this, this panel discussion. Now, in a voting problem, we have some things have to be there's always some things that are sort of predefined. We're going to have a set of voters, so n, 1 up to n. In my case, I have 3 voters, 1, 2, 3. We're going to have a set of alternatives, or items that these voters are going to have preferences over. In particular, we assume that voters are able to rank these different alternatives. So in this case, I have 3 voters, 1, 2, 3. I have 4 alternatives from A to D. And then I have that each of my voters have actually ranked the alternatives. So I have that voter 1 likes A more than B, B more than C, and C more than D, for example. And then the question becomes, well, these individuals, they all have different preferences, so what is the correct group ranking for the entire group? And what is sort of the top alternative? And what can we say about whether that's what ranking we choose or what alternative we choose is a good ranking or a good alternative? Is it reflecting the underlying values of the participants? So one thing I've been particularly interested in is what happens if we do not have full information as to what the preferences of our agents are. Again, these agents could be humans, or they could be pieces of software, it could be robots, they could be your cat. I really don't care what the individuals are, just that they are individuals and they care about different things. A lot of the work in social choice theory gives us sort of proper ways of answering this question. So they tell us what it means to have sort of the right outcome. Social choice theory will tell us things like what's the right way to aggregate all this preference information under the assumption that we actually know what those preferences or what those alternatives are. So we know that agent 1 likes vanilla ice cream more than chocolate ice cream, more than strawberry ice cream, so on and so forth. Instead, what my group has been looking at is a situation where what happens if we don't have this information? Now, we might not have this preference information for a whole bunch of reasons. First, maybe people want to hide this information. They don't want us to know their ranking over ice cream flavors. Secondly, maybe they can't even specify it, or we haven't asked them enough questions, and so they're still kind of undecided as to what their underlying ranking is. And so if you have this incomplete preference information, we still would like to be able to make decisions on behalf of the group. So in one line of research with a former graduate student, John Doucette, and a colleague, Robin Cohen, we asked, well, can we use, if we have some limited preference information, that's giving us, but some of it's missing, well, that's giving us some information there. Can we use machine learning techniques in order to impute the missing information and then make decisions based on this sort of imputed information? And can we say something about the quality of the decisions that we are returning? And the answer is yes. You'd be surprised at how accurate we can be just by using different learning techniques to fill in missing information. And more theoretical work with my PhD student Vijay, who's sort of sitting right there, we've asked questions like, let's assume that our voters or our agents have only given us a little bit of information about their top-ranked alternatives, but nothing kind of at the bottom of their rankings. Again, for whatever reason. Maybe they just can't be bothered to tell us, maybe they want to keep that private, and so on. And then we've asked questions like, if we have only this limited information, what does that say about the election? Can we compute that we're running? Do different structures of the election, can we figure out what the right outcome is? And more importantly, how hard is it to manipulate a particular election or set of election rules if we have missing information? And so we've used tools from computational complexity to provide sort of guarantees about like how robust particular voting rules might be. Another thing that we have been interested in is strategic voting. This is the second point that I find fascinating. What happens if individuals can be strategic in their decisions? Now, we're in Canada and we vote in federal and provincial elections all the time, and kind of a sort of joke that one of the national sports in Canada is being strategic in how we vote. However, to vote strategically appropriately, to swing the election in the way that you might want it to, requires an awful lot of information about how you think the other voters are going to be behaving. Because what the best way for me to vote is going to depend on how I think Ian's voting, or how I think Alex is voting, and so on and so forth. And with another PhD student of mine, Alan, also sitting here, what we've done is that we've looked at sort of iterative strategic voting, particularly in an iterative context where agents are getting information about voting results in the past or over time, and can sort of update their votes. In the situation where the agents are embedded in social networks, so in particular, individuals do not have full information about how the whole population of voters are going to, what they're going to be doing, what their preferences might be. Instead, the information that they have, which they are going to base their strategic decisions on when it comes to voting, is limited by the underlying social network that they find themselves embedded in. And then we have asked questions such as, does the network structure affect the strategization that's going to occur? Are there other network properties that we could maybe highlight, which is going to allow us to determine how much strategization is going to occur? Is strategization kind of a bad thing for society broadly defined, or is it a good thing, and so on and so forth? Okay, we've also asked questions about how do you sample information in large networks, also with Alan in a former postdoc. Then as my last example, as the sort of problem that I'm really interested in, is actually very, very applied and has to do with, in the context of wildland fires. And this is actually one of my favorite domains to work with. So in particular, I don't think I really need to convince anyone here, who's particularly been following the news over the last few years or even the last few weeks in California, is that wildland fires are becoming sort of more, coming with increasing frequency, and sort of these larger fires which are harder to keep under control. So in this context, I and a bunch of other researchers have been looking at resource sharing across different agencies in the Canadian context, so as to figure out how resources at the national level should be shared across provincial boundaries, so as to ensure that they can be used sort of in the best way possible. So they can be located in sort of provinces which have the highest need. Now, there are some fascinating incentive and strategic issues that arise here, because if Ontario sends resources over to BC, then Ontario is taking on increased risk. And so there's interesting preferences that we have to try to model appropriately in order to capture what both the preferences are as well as what the incentives might be. At the same time, there's hard computational problems because you have these underlying logistical problems that have to be solved at the same time. And so, as I said, so this is like a situation where we are looking at exploring how do we design systems, again, which take into account limited information, sort of complicated preferences, particularly where there's high risk, in strategic settings, where there are interesting computational constraints that also have to be handled, and then in a particular applied domain. Okay. And thank you.
So I'm the oddball here. I'm a sociologist, and so lots of you may be wondering, how exactly does a sociologist study technology? Basically, I study how ICTs change our interactions with each other. And so I teach courses on tech and society, surveillance and social control in games and gamer cultures, and a grad course on how bias, such as racism and sexism, become inadvertently designed into our algorithms, our software, and our interfaces, as well as sort of our AI techniques, and how we can identify and respond to these sorts of things. And so I started my research life more than a decade ago as a criminologist. And so I was investigating exactly how we can get people to behave online when we don't have physical bodies to punish or to put in jail. How do we entice anonymous jerks to behave when banishing them just means that they sign in again with a new account name? And when, if, for example, a virtual item is stolen, we can't go to our local police. First, because they don't know what the hell we're talking about, but because they don't have the technical expertise or the resources to address the issue. And our legal system may not define this as an actual harm. And even if they did, any responses would actually require international cooperation between the countries, let's say the server that hosts the server the item was hosted on, and that of the country of the perpetrator. And each of those countries would have to have their own legal regimes with different definitions of whether a crime has actually occurred or not and how to respond to it. And so the sort of solution is that whether we're aware of it or not, a lot about how we behave online is actually structured through code, right? They become the laws of our online spaces. And they are effectively designed by those who create our software. And some of these people design these laws with lots of forethought and testing, but a lot of the times these are sort of haphazardly built. And so it didn't take me very long to start working with game developers who were struggling with some of these very same challenges, right? Toxic behavior. And for example, how could they build tools that empower players to create and share levels, but simultaneously prevent user-generated content from spelling out swear words or looking like this, right? And so the solution becomes not just a technical solution of software restrictions, but also social strategies like reputation systems and reporting systems to manage this sort of behavior. And so from there, my work quickly adapted to tracing the impact of data-driven design in the game industry, which allows developers to watch what individual players are doing in-game and adapt in response, often in real time, thus enabling more individualized and persuasive technology. And so this sort of persuasive technology is always enticing us to spend more time on our devices. And so in other words, you know, we don't like to use this term, but how do our devices get us to become addicted? And so I'm going to talk briefly about a couple projects with grad students. And so I'm working with a few of them right now to look at how persuasive tech is employed via mechanics such as loot boxes, basically random reward schedules, that compel players both to what's called convert, to become spenders in free-to-play games, but also to spend more time on their devices. As sociologists, rather than, let's say, the psychologists working at University of Waterloo's Gambling Research Lab, we're mainly interested in how these practices are developed by software developers and how they're become popularized and spread through different sort of games and other apps, how they become regulated, and the economic pressures on these developers to incorporate what the developers themselves feel are addictive or unethical design practices. And so this links to a larger project that collaborates with small game studios to study economic precarity, labor, and creative work in Canada's game industry, which is one of the largest in the world and contributes more than $3 billion to our annual GDP. And so in the few minutes I have left, I want to briefly sort of take another route and talk about another project with a grad student that takes a different approach to understanding the impacts of 21st century tech. And so this is where I'm going to link to both Ian and Kate's talk. And so we know that sites such as Facebook collect incredibly precise information about us, using not only the data that we choose to share, such as the things that we post on our profile, but also they look at our friends lists and the things that we like and reshare and repost. And they use machine learning methods like those described by Kate to make predictions, to fill in the blanks about all the things we don't share, such as imputing what they think our intelligence level is, or whether from our selections they think that we're pregnant or not, or whether we buy children's cereal. And so you can see behind me, this is sort of Facebook talking about what kind of information they collect about one user, likely to engage in politics, liberal, and you can dig down. And so they can tell you that, if you're an advertiser of children's cereal, they can help you place an ad in 14.8 million sort of people who are likely to buy lots of children's cereal. And so Facebook and Gmail and YouTube and free-to-play games, they're all free because we're the product, right? Access to us are what's being sold to third parties, like advertising, in what's called surveillance capitalism. And so this is what most or many privacy and surveillance researchers are looking at when they're studying Facebook. However, my student Brian and I are taking an entirely different approach. Because when he was speaking to queer folk, he noticed that they don't care about surveillance capitalism. They're more worried about the immediate harms of being accidentally outed by those they care about. And there really aren't effective privacy-enhancing technologies to prevent this just yet. For example, if you're an active part of the Muslim community in town and you wear a glow t-shirt supporting sexual and gender diversity, a friend's innocent picture that they take of you could be automatically posted and tagged on Facebook using facial recognition software, inadvertently outing you to everybody on your social network. For example, your feed could be here on your cousin's page, your auntie is watching behind him, she sees you at this sort of thing, and then you maybe sort of face banishment or expulsion from your community, or even worse, right? And so Brian's embarking on a project collaborating with communities of queer activists to better understand how they use different social media tools and strategies to maintain their voice and their activist presence, focusing on how they keep their sometimes conflicting social groups separate. And so our end goals here are to rethink surveillance theory, to both sort of queer it and take into account networked rather than top-down models of information sharing. So right now, most privacy tools are to help us to protect from corporations gathering our individual level data, but how do we build privacy tools that help collectivities, groups of people, keep and share certain amounts of information with the lowest level of friction possible? And so we're working with these communities to suggest both social strategies and design modifications that could be applied to existing privacy-enhancing technology with the aim of allowing those users to fully participate in online life without constant paranoia about accidental exposures and the harassment that may result. And this isn't just sort of a question about sort of people who are queer and Muslim, but it's a question about every time we have conflicting identity markers. For example, if I am a conservative voter and I am in sort of a liberal arts program in the university and I got out to the rest of my faculty members that I'm voting conservative, that could actually have implications for my career, right? Or if I'm a feminist, but I also work in sort of a game industry, sort of, and that gets out, those often conflict. And so your Twitter feeds have to be exactly separate, or you have to have two different Twitter feeds for those two aspects of your identity. So these tools have, we hope will have wider ranging sort of implications. And so regardless of the project, well sociological methods such as interviews, surveys, and ethnography working with both developers and people who use technology effectively expose the negative implications that can occur of 21st century tech. It's also by collaborating directly with folk like developers and engineers and computer scientists that we can unpack the root causes of these effects, find the most effective ways to address them, but also hopefully to prevent them from occurring altogether. Thank you.
Hello, can everyone hear me? Hi everybody, I'm Alex. So I'm just gonna, I'm an engineer, so I'm just gonna get straight to the point and talk about some of the technologies that I try to build. I love to build stuff. So some of the technologies that I try to build and hopefully has some kind of positive impact on society. That's my closest, I guess, link to society right now. So right now, there's a new, they call it a new revolution in AI. It's persists, but now it's in the media with big benefits to society. You can't right now flip through Economist or Fortune without seeing the word deep learning, AI, something or other. All you have to do is just start a company that has .ai, deep, and then you make billions. So it's a big thing, but what you'll see is that there's actually a huge inequality in terms of AI. So a lot of the benefits that are seen are people who can actually afford to do it. So we have Google's, Amazon's, Microsoft's, with their vast amount of resources. They're able to build things because they'll say, okay, we built something that beats everyone at Go. Great, except we spend millions of dollars. We have 300 PhDs working around the clock for 2 years, right? Not everyone can do that. So one of the goals in my lab is that we would like to democratize and proliferate AI as a commodity for anyone, anywhere, anytime. So whether you're a big business like Google or a small little farm in southern Japan, you should be able to leverage the power of AI to help improve your business. Also, anyone young or old worldwide should be able to benefit from the power of AI, whether or not you have substantial amounts of money. So one of the things I've been working on is how do we actually make powerful AI like deep learning possible for operational scenarios. And I'll talk about some of the key areas that has been considered challenging. So there's been an enormous challenge in getting operational artificial intelligence, particularly in deep learning, as a widely adopted integral part of everyday life. And the three key challenges that I'm going to talk about here, as well as mainly because I'm actually working on some of the stuff, is unique AI. So how do you actually make your AI unique? So in business, a lot of people say, I like to use AI for X, I like to use AI for Y. The quick question is, what's the differentiator? If it doesn't make any difference to you, it's not going to set you apart. Why bother? Right? So I'm going to talk about how do you actually create unique AI. The other one is explainable AI. Right now, especially with things like deep learning, people treat it as largely as a black box. Information goes in, question mark, question mark, question mark, and then something comes out. How do you do it? You ask it, I have no clue, right? That doesn't really instill a great sense of confidence. Imagine you go see a doctor, and the doctor said, you're about to die, you have, let's say, grade 4 cancer. Why? Because this neuron fired, this neuron fired. Like, if you heard that from your doctor, you're just going to go and look for a second doctor, right? And then finally, about scalability, scalable AI. Right now, great, Google can do it, Amazon can do it, but now it's completely locked into those infrastructure, right? So how do you actually get informed that, great, it works well in the cloud, but also works well on edge devices, right? So that you can use it no matter what kind of computing device you have. So these are the three challenges I've been tackling in our research group, and here are some of the things that we've tried to do towards that. So towards the challenge of unique AI, one of the things that we've been working towards is how do we actually get unique data to feed AI? Because if you have garbage in, garbage is going to come out, right? So if you have poor quality data, then no amount of AI magic is going to make it work. So we've been trying to develop instruments to actually give you high quality data so that you could get much better predictions and inferences. So in one example, if you take a look at the left, that's your standard T2 weighted MRI that you see on shows like House, ER. They might sometimes like to hold it printed on slides. Nobody does that anymore. It's all digital anyways. So I don't know why you would want to print it and look like that, but that's what they're usually looking at. So here is a prostate right there. There is an enormous cancer right there, and it's been proven they took it out, so on and so forth, right? If you are any radiologist, even the most expert radiologist, you won't be able to find it. Why? Because it's not in the data. So if I use that to train AI, it's not going to get any better. So what we did was develop a new modality called Correlate diffusion imaging. So a new form MRI that's designed specifically to seek out hard-to-find tumors. So if I were to ask you on the right, which is based on our modality, where the cancer is, it would be almost impossible for you to not get the right answer, right? So when you have something like that and you feed into AI, the performance increases exponentially. And that's what we've been able to see in our research. So that's one example. Another example is Ada. So this is an AI dermatologist assistant that we've built and actually commercialized. It was recently announced as one of the top 20 Canadian most innovative technology companies. So that's how we're translating our research and technology directly into industry, hopefully for good in this case. So what we've done is, well, a lot of people say, oh, I'll just go and I'll take a picture and I'll take a mole selfie, right, and send it to my doctor. Guess what? Even with a doctor, they look at it, there's not enough information on the surface. So what are you going to do? What we've done is we built a new system that actually does deep tissue sequencing. So we'll actually get you molecular information underneath the skin. And when you feed that into AI, not only can you actually do a really good diagnosis, it could also kind of tell you why. So another example is Chi, working with Rich right there. Hi, Rich. So what we did was develop one of the world's first and only, I think it's the only, we'll see, blood flow imaging system that allows you to see both arterial flow as well as venous flow. So it's actually got quite a lot of widespread media attention, so we're quite happy, and we're trying to test it in different clinical institutes. And with this kind of wealth of information, hopefully we're able to build better AI around it. So those are just some examples on the unique AI side. I'm just going to keep going. So here are some of our efforts towards explainable AI. So how do you actually achieve explainable AI, especially explainable deep learning, to get away from this black box and unveil the inner workings? So if I have data and I show it something, why did it make that particular decision? So what we did, and we actually won something a couple days ago. Yeah, I wasn't there, but anyways, it was kind of cool. My students was very happy. He wasn't actually not there when they got announced. So anyways, it didn't help too much. OK, either way, I'm just going to keep going. So this is an example of where we're actually applying it directly for clinical diagnosis. So remember we talked about, you ask the doctor, why did you make that diagnosis? They're not going to say, I have no clue. They're going to say something, right? They're going to say, here's my rationale. Great. With a deep learning system, you pass, in this case, a fundus image in. It goes in, and it makes a prediction about what grade of diabetic retinopathy it is, right? But right now, I have no clue. What's the reason? A couple of neurons flying. So what we did was create a system called Clear that actually tries to make the decision a lot more clear. So instead of just showing, it made that particular prediction, it's, in this case, it's proliferative diabetic retinopathy. What it also does is it generates a full visualization. It's really dark here, but it'll actually highlight the areas in which it actually made the decision. So for example, it'll say, this set of vasculature is associated with moderate diabetic retinopathy. This vasculature is normal, so on and so forth. So now even for a doctor, when they use it, it could allow them to look for hotspots. Instead of searching through the vast amounts of data, they can actually look at specific areas that could be indicative of a particular disease. And of course, we had to apply it to finance. So what we did was, just for kicks, we built a predictor for the S&P 500. So it predicts whether the index goes up or down, right? Great. This one goes down. It says it goes down. Great. It goes up, great. So it makes a good prediction, but what happens when it goes wrong? How do I actually believe anything this says? So for a Clear system, what it does is it also tells you the dates associated with that particular decision, right? It thinks it's going down because of these sets of dates as well as those sets of dates. And if you zoom into those particular dates, what it'll also tell you is the factors during those days that actually led to this particular decision. Was it because of trade volume change? Was it because of high or low, so on and so forth? So being able to explain what you build becomes very important. And now the last thing I'm going to talk about, I'm just going to do this quickly, is how do we actually make AI scalable or deep learning scalable in any operational environment? So the underlying idea that we had was, can we actually evolve deep neural networks naturally into highly efficient yet powerful deep neural networks? And the answer is yes, because we won something for it. And so just as a kind of an analogy, so people, I used to give millions of years of evolution, blah, 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 right? So let's bring home a more practical example that's more, I guess, appealing to everyone in the audience. So some people have seen this, others may not have. This is a nice plot from a cool study where they are trying to study the number of total synapses in your brain as well as the synaptic density over your lifetime. So what you'll see is that you reach your synaptic peak in your lifetime when you're around 6 months old, and then it's just pure downhill from there, and it just keeps shooting down, right? The only way you could get any lower is when you die. So then the question is, am I just getting incredibly stupid as I get older? I don't like to tell my kids that. So my rationale is, when you're young, people say, you play hard, right? When you get older, you say you play smart. So what's actually happening is that you're kind of evolving your brain such that things that are not really necessary to your daily lives or what you're trying to do actually kind of, goes away. So you're actually being more efficient. Right? So you're not getting stupider. And so we took this approach and we applied it to building deep neural networks. So we're able to get deep neural networks that were orders of magnitude smaller and was just as smart. So this enables for things like multi-camera video analytics on a small mobile chip, which we're able to demonstrate. And getting the power of operational deep intelligence directly into your hand. So be it a small box like this or an old iPod. If you guys want to try it, this actually works. I'll show you sometime. And that's pretty much it.
Thank you, panelists. I found much of what you said to be very encouraging. I found much of what you said to be very discouraging and even alarming. And let me explain why. I enjoy life because I can make decisions myself. I like to drive my own car. I don't want to ride in a car that's driven for me. I like to make decisions about where I go for lunch, how I vote. I don't want algorithms driving how I do things and the decisions I make. I sometimes have nightmares about this. I worry about becoming a robot and having a dull, uninteresting life as distinct from what I have now. Do I need to worry or do I not need to worry? I submit in closing that every technology has both advantages and disadvantages. And I submit that the same is true of all of the technologies that you people have presented today. And that's to all the panelists, and indeed to the audience.
I could comment about that first. So, no, I completely agree with you. So, one of my main mentalities, working with, artificial intelligence, I never really liked the name anyway, so I could change it anytime. So, I prefer more the augmented intelligence approach. I know there's many decisions that you would like to make. You like to drive your own car, you like to think for yourself, which is great. I heavily promote that. I also tell that to my kids all the time, think for yourself, just leave me alone. But one of the key things is there are so many things in life that you might find mundane that you don't want to make a particular decision on. And there are also situations where you might want to get a second opinion. So with some of the technologies I'm trying to build, especially on the clinical decision support side, it's not to replace a doctor. It's to help them have additional knowledge drawn from data so that they could either make their lives easier or make it more efficient. As you know, there's a big backlog in terms of people that needs to be screened each day. So if it could help them be just as accurate or even more accurate, but allow them to screen through a lot more patients, I think there's a lot of good with that.
I hope you can hear me with this. I also, I'm going to be non-controversial, I actually agree with Alex. I think, particularly in the context of AI, the goal, in my view, is to have that these AI systems complement sort of human decision making. Now, what drives my research is that I want to understand kind of what the trade-offs are that we're making when we are automating some decisions for a group versus leaving it all just to individuals, particularly taking into account kind of how computation is going to play a role. But when I'm optimistic, my view of the future is that we will have these systems which are working side by side with human decision makers, and so that we can offload sort of some decisions to the systems but still maintain some control ourselves, but that this offloading and this transferring back and forth between human decision makers and these systems will be sort of fairly transparent and not go sideways badly.
So I'm going to add a comment to that, and maybe this is something that Ian and Jen might want to respond to. That's very helpful when there is time to make these decisions or to evaluate them. But if we're thinking about, for example, autonomous vehicles, where there are vehicle-to-vehicle transactions going on that the user isn't even aware of, and decisions being made vehicle-to-vehicle, where does the human lie in that, and what role, what are the privacy issues related to that? So maybe we could have Jen and Ian comment on that.
So I think even more problematic than that is what Kate and Alex were saying. We want the AIs to augment the decision-making process. I think the unaddressed problem is that this technology is not evenly distributed, and it will be augmenting the decision-making process for people who are already powerful, probably at the expense of people who are already underclass. And that's something we would really like to avoid, right? So we want to make sure that the people who get decisions made for them now don't have that problem get much worse when these decisions are automated but out of their own control, right? It could be that the AI is very helpfully suggesting to people how to arrange their affairs such that it benefits them most, but then it's maybe benefiting them at the expense of other people. And there's a phenomenon called social sorting where people are presented with limited choices, and depending on who they are, the choices they are presented with are restricted so that they don't have the option to do what other people might have the option to do. And I think that's why we have to take care to say that when we are saying these technologies should aid people, which absolutely they should, and should not just be making decisions on behalf of everybody, but even so, if they're making decisions with the aid of some people, they still might be making decisions on behalf of other people without their knowledge or consent.
Yeah, I would like to jump in there. I think I don't doubt that design intent is to make these systems transparent, to build them so that, you know, if doctors are searching for cancer, that they're doing it in coordination with these sort of machines. But our design intent, once something that we build goes and lives out in the world and is taken up by different users and modified, our best intentions sometimes fail, right? And so the systems that we create to spot breast cancer could be modified and adapted to other uses that aren't as sort of beneficial to all and clearly beneficial to all. And so then where does our line of accountability lie? Was that in the original sort of creator, the person who built the system, or the person who modified the system, or the corporation who sold all the different elements? And so this is a really, really complex question, mostly because that the way that many of these systems live in the world once they leave the University of Waterloo has to do with profit motive, right? And so the sort of decision-making systems that Kate is working on are awesome and amazing, but the first people that are going to use them are corporations who can hire all of Kate's students and pay them and figure out, okay, well, how can we use this sort of system to figure out which of our users are pregnant? Because we know that when somebody is pregnant or just married, they're going to change their consumption patterns, and they're actually going to click on those ads and start buying these sort of things. And so this is the issue, is that once things leave Waterloo, how can we still sort of remain accountable to them and hold people accountable for those unintended uses down the line that create these unequal outcomes that we didn't expect?
So you guys sort of touched on what I was going to ask. A bit different from John, I like to be told where to go for lunch sometimes. I mean, if I'm in a new city and I don't know what a good restaurant is, I think it's great. I like to get my suggestions. I just sort of rely on it most of the days, but it is scary, like Jen was mentioning, that I don't want all the decisions to be made for me. So I guess my question is, is this out of a hand right now? Like, is this technology just like evolving? Who's controlling it? You know, it's good, but also it's a little bit too much. So, for example, Facebook, there's a few people that have left Facebook, and all this media is coming out because they started working on something that they thought was good, and now it got out of hand, and all of a sudden there's moral implications, ethical reasons why they left the company. So I guess my question is, who controls it? Do you, the inventor, control this? You know what I mean? I don't know. It's just sort of. So you're creating all these amazing things,
Sure,
all
yep.
of you. So once a company gets a hold of it, do you get to say, okay, I don't want you to use it for that? Or it's just out there?
Well, once it's out there, it's very hard to prevent other people from using it. I mean, the whole point of research is to disseminate the research so people can use it. There might not be too much control of how people use it, but I think that's the burden, especially since we're an academic institute, to actually educate people to use technology properly, right? I think it's more in the education.
So we're all going to know how to use AI properly?
Uh, I'm going to try to run some workshops, and then you can feel free to come on over.
All right, I think that it's time, unless you've got a burning, do you have a burning statement to make, Kate?
I don't know about burning. I think that as researchers, we have a responsibility to highlight both the strengths of our results and the systems that we build, but also the limitations. And so one of the things that my group tends to work on, now again, quite theoretical in nature, is kind of what are the assumptions that are going on into the system? How, if we change the assumptions, which is important in practice, how are our results going to break? And I think it's extremely important to do that in no matter what sort of research setting that you find yourself in, so that you can then sort of present the work and say, here's what it's good for. If you deviate in any way, these are the repercussions that we've been able to identify. And it's just sort of a useful way of thinking about research results or technology in general.
So Alex, Kate, Ian, and Jen, it's really great to have you working on these complex issues. We really appreciate the effort that you put into it and the thoughtful work that you're delivering for the communities as a whole. And thank you for the presentation today. Let's all thank them once more.